This is Suvat, and in this video we're looking at dynamics and Newton's second law. So Newton's second law states that the resultant force acting on a particle is proportional to the product of the mass of a particle and its acceleration. In easier terms, that means that F, which is the resultant force, is equal to ma. Now m is the mass and a is the acceleration. The resultant force is measured in newtons, the mass is measured in kilograms, and the acceleration is measured in meters per second squared. So the question we have here says that a van of mass of a ton is travelling along a horizontal road. So the total resistance to its motion is 400 newtons, and the driving force is 1,600 newtons. And we have to calculate the acceleration of the car. So the first thing that we can write in this question is F is equal to ma. And then we have to see which ones of these we have. So if we remember that the resultant force is going to be the driving force, which is 1,600, take away its resistance force. So that means that F is going to be 1,200. Now this is equal to ma. Now we have mass because it says mass of a ton. Obviously we have to use kilograms as it says here, and a ton is just 1,000 kilograms. So it's going to be 1,000 A. And then now we have to find the acceleration. So 1,200 divided by 1,000 A is going to be 1.2 meters per second squared. So the next two questions are involving Suvat equations within. And the first one is asking work out the resultant force on a bike of mass 100 kilograms that goes from 15 meters per second to 12 meters per second in 20 meters. So in this question, if we were looking at F equals ma, we're looking at what F is, and we have m but we need a. And in order to get what a is, we need to set up a Suvat equation. So in order to set up a Suvat equation, if you don't know, I will go into it this video, but watch my video on Suvat equations, which goes into in further depth. But we have this S, U, V, A, and T. Now we know that S is going to be 20. U is going to be 15. So initial speed. Final speed is 12. A is what we're trying to find out. And then T we don't have. So that means without t, the Suvat equation that we'll be using is v squared equals u squared plus 2as. So therefore, v squared, 12 squared there, is going to be 144. Then u squared, 15 squared, that's going to be 225. And then that's plus 2as, which is going to be 40a. That means that 40a is going to equal minus 81, and therefore a is going to equal minus 2.025. And that is meters per second squared. But we don't have our final answer yet, as it's asking us for the resultant force. So in order to do the resultant force, we're going to have F equals ma. So that means that F is equal to m, that's 100, times by a, which is what we've just worked out, minus 2.025. That is equal to minus 202.5 newtons. So then this one here is asking if there's a train of mass 50 tons accelerates from rest to a speed of 10 meters per second over a distance of 50 meters. So if the total resistance to motion is 3,000 newtons, then work out the driving force acting upon the train. So again, what we're needing here is we're needing the acceleration so that we can work out the resultant force and then work that knowing that the resistance to motion is 3,000 newtons, and that will mean that we can work out the driving force. So again, we're going to have to set up this Suvat equation, and it will go similarly to the first one we did, as again, we do not have t. Acceleration is the thing we're trying to find. V, that's the final speed, and it's going to be 10 meters per second. U is the initial speed, and as we have from rest there, U is going to be 0. And then S, that's going to be 50, and that's because it's a distance of 50 meters. So therefore, we're going to be using V squared is equal to U squared plus 2AS. So V squared is going to be 100. Then U squared is going to be 0, and 2AS is also going to be 100A. So that means that A is just 1 meter per second squared. So now we have what A is, we can now work out what F is. This is the resultant force, remember. So the resultant force is going to be the mass, which is 50,000 kilograms. As remember, in 1 ton there are 1,000 kilograms, times by 1. So the resultant force is 50,000 newtons. But that is not our final answer. As in, like the first one, it did just ask for the resultant force. This is asking us for the driving force. Now, the resultant force is going to be that driving force minus the resisting force. That's equal to 50,000. Now, it says here that the resistance to motion is 3,000 newtons. So therefore, the driving force minus 3,000 is equal to 50,000. As a result, what we're ending up with is that the driving force is equal to 53,000 newtons. So the next question is slightly harder, especially question B. And it says that two particles A and B have mass of 2 kilograms and m kilograms respectively, where m is going to be less than 2. So the particles are connected by a light inextensible string which passes over a smooth fixed pulley. Now initially A is 3 meters above horizontal ground. The string is released from rest with the string taut and the hanging parts of a string vertical. After A has been descending for 2.5 seconds, it strikes the ground. Particle A reaches the ground before B reaches the pulley. So A is asking us to show that the acceleration of A as it descends is 0.96 meters. And the fact that m is going to be less than 2 here means that it's extending in this direction. This is how it's falling. So A will go to the ground as B is going to be pulled up there. So this one requires a Suvat equation in order to work out the acceleration. And that's because we have a multitude of things in it, with the exception of final velocity. So we can say that final velocity, no. And then A we do have, but T is going to be 2.5. The initial velocity is going to be 0. Now again, that is because it says it is released from rest there. And then S is going to be 3. That's because it says it strikes the ground and it started 3 meters above. So therefore, without V, the Suvat equation that we will be using is going to be S is equal to UT plus half AT squared. So therefore S is going to be 3, UT is going to be 0 because U is 0, which means that that is going to be 3 is equal to 3.125A Therefore A is going to equal 0.96 meters per second squared, which we know is right because it says in the questionnaire. B is slightly more difficult there, and it is going to be using a bit of that idea of F equals ma. So for this one, we need to know where tension is acting. And tension is going to be acting there. Tension will also be acting up there. So to start this off, we know that going down here is going to be 2G. And then we know that going down here is going to be mg. Now we will be doing all of this in another video in more depth, but g is basically gravity and it's equal to 9.8 meters per second squared. So we could be writing that instead as 2 times 9.8. But therefore, for B, we're going to say that 2g going down minus T, which is the tension in this one, so this is the vertical forces, is going to be equal to 0.96, which is the acceleration, and then the mass is going to be 2. That's because, so the resultant force, that's the force going down minus the force going up, is going to be equal to the resultant force, which we've gained from doing that. So therefore, T is equal to 2G minus 0.96 times 2 that is equal to 17.68. And that is newtons. So therefore though, we also know that T is acting here. So now we know that that is going to be 17.68. And for this to work, we are going to say that T, which we have here, in fact, is going to be 17.68. And the resisting force to T is going to be mg. So that's minus mg. Now that is therefore going to be equal to m times acceleration. We already know that the acceleration is going to be 0.96, so that's 0.96 m. Therefore, let's do some rearranging here, and we're going to get 17.68, and that's going to be equal to mg, which we can say is going to be 9.8 m plus 0.96 m therefore 17.68 is going to be equal to 10.76 so therefore m is going to equal, rounded to 2 decimal places, 1.64 kg. And we know that's right because it says it in the question. So here we have our final question, which involves systems of forces, but also F equals ma. So A is asking for the acceleration of the particles as the system moves under the action of a 30 Newton force. And we know that we have here two particles, P and Q. This has a mass of 4 kg. This one has a mass of 6 kg. They are joined by a light horizontal rod. Now the particles are initially at rest when a constant force of magnitude 30 newtons is applied to Q, as shown in the diagram. So the force is applied for 5 seconds. And during that motion, the resistance to P has a constant magnitude of 2 newtons. So that's resistance to P. And then the resistance to Q has a constant magnitude of 4 newtons. So in the first question, where it's asking for the acceleration of the particles, we're going to treat this as a whole system. So that means that forward we've got 30 newtons, and then back we're going to have 6 newtons. That's because we've got the 2 plus 6. Those are the forces going backwards, the resisting forces. That is going to be F, and then we've got looking at MA. So the mass is going to be both the masses added together, so 4 plus 6, 10. So that's going to be 10A. Therefore 10A is equal to 24. A is therefore going to be 2.4 meters per second squared. Now on to question B. As B is asking for the speed of a particle after 5 seconds. Now as you've got this time dimension here, we're probably looking at a Suvat question. So S, U, V, A and T. So in terms of S, that is the one thing that we do not have in this question. Then U is going to be 0, it's initially at rest. V, that is the thing we're trying to work out, as we're looking for the speed after 5 seconds. A, we've just worked out, is 2.4, and then T gives us in the question is 5. So therefore that's just going to be the simplest Suvat equation of V equals U plus AT. So V is equal to 0 plus 2.4 times by 5. Therefore V is equal to 12 meters per second. So now we have that. The next question is asking for the tension in the string as the system moves under the action of a 30 Newton force. So this time tension is acting in this direction here. That is tension there. And in order to work out this question, we're going to, instead of working out as a system of force, we're just going to use P. So we can look at the forces going forward of P, and then also the forces going back. So the forces acting in front of P are tension, and the force resisting this is going to be that 2 newtons. So that is going to be equal to mass times acceleration. Its mass is 4, and its acceleration is 2.4. Rearranging that, we're going to get that T is equal to 11.6 newtons. Now looking on to D. As D asks for the distance moved by P as the system decelerates. So again, we will be looking at a Suvat equation, but we will have to find out what A is in order to get this Suvat equation to work. But we'll start off by putting the Suvat equation in. So we know that S is the thing that we're trying to find out. We're trying to find out what the distance is. We then know that U, that's going to be 12. Now we know it's 12 because of this question here. The final velocity at the end of that 5 seconds was 12. So then after 5 seconds, the initial velocity is going to be 12. V is going to be 0 because it's coming to rest. Decelerates to rest there. A, that's what we're just about to find out. As T, we do not know. So if we're going to work out A, we can find out that minus 6 is going to equal 10A. Now again, we're treating it as a whole system, and we know it's going to be minus 6 because we have this 2 newtons back, 4 newtons back, and we don't have any of this 30 newtons. This 30 newton has been taken away because it says that after 5 seconds the force is removed, but we still got those resistant forces there. So we got -6 going back, and then it's going to be 10, but 10 is the weights of both of them, so 4 plus 6 times by acceleration. So therefore A is going to be equal to minus 0.6 meters per second squared. So that's minus 0.6. So therefore the equation we will be using is going to be v squared is equal to u squared plus 2as. Therefore 0 is equal to 144 minus 1.2 s. So 1.2s is equal to 144. Therefore s is equal to 120 meters. Right, final question now is asking about finding the thrust in the rod as the system decelerates. So this time, thrust is going to be acting in this direction as it's pushing this forward, and then we have this 2 Newton here. So that means that both of them will be acting in the same direction. So we can say that thrust plus 2. Now that is going to be equal to ma. Obviously F is equal to ma. We've got m is going to be 4. We're just treating it as p this time. So m is going to be equal to 4, and that's going to be times by 0.6. Now we've made it 0.6, not minus 0.6, as by saying it's t plus 2, not minus t minus 2, we're saying that this is now a positive direction as it's moving in this direction. So that's why it's 0.6, not minus 0.6. So that means that thrust is going to be equal to 0.4 newtons. So thank you for watching this video, and see you soon. Bye.